So we're going to attempt our first type of metric conversions. Now, within the series of these videos, you're going to see 4 different types of metric conversions that are possible. And I'm going to divide them up into a series of topics. The first type of metric conversion that we're going to talk about, I call a one-step conversion because it's only going between a base unit and a single prefixed unit. There's not going to be any other prefixes or anything involved. Let's jump right into a sample problem so you can see what I'm talking about. So I just threw up our chart of equivalence statements for the metric system over to the side of the screen so you can kind of make sure that this is constantly in the background. Honestly, before I start any metric conversions, I usually like to write this system of both the prefixes and also those 10 to the values on the side of my paper for quick reference. It just helps to make sure that the right numbers are going with the right units as you're going through the problem. So here's our first problem. Let's convert 23.7 hectograms into plain grams. Well, the first step to metric conversion is to take the number that you're given, that's 23.7 hectograms, and turn that into a fraction. Now you can turn any number into a fraction by putting it over the value of 1. So here we go, putting it into a fraction, that 23.7 hectograms. I've simply put it over top of 1, and I'm ready to start my problem. The second step of metric conversions in this field goalpost system is to take that unit hectogram. I don't want that unit anymore. I want it to be able to cancel out. So I'm going to place it on the bottom of the next fraction. So hectograms I know must go to the bottom of my second fraction to be able to take advantage of that property of multiplying fractions, that you can cancel out anything that's the same between the top and the bottom. Now it's time to go shopping. I need to find an equivalence statement to put into this zone. Now this fraction can only equal 1. So I need to put the numbers from a single equivalent statement in that. Now what that means then is, in essence, I'm really not changing that 23.7 hectograms. That measurement is still going to represent that distance. We're just putting it into other terms. We don't want to call it hectograms anymore. We want to call it grams. So let's go shopping in that metric conversion store of ours and see if we have an equivalent statement between grams and hectograms. And in fact, we do. It's right up here highlighted in green. So the next step is I just need to put the right letters and numbers in the correct places in this fraction. Now what's nice about carrying the unit down to the bottom first is it kind of puts a little pin in where everything is going to end up going. I already know that hectograms has to be on the bottom. And I'm just going to simply put the number that goes with that from my equivalent statement down into my fraction. So you can see already in my chart, a 1 goes with hectogram. So I need to put a 1 in front of the hectogram in my problem. And now to fill out the top half of the fraction, we're going to use the other half of the equivalent statement for that. And that's the 10 to the second grams. So 10 to the second grams has to get filled into the top half of my fraction. Now what I'm allowed to do is cross off like terms. So my hectograms now I know can cleanly cancel out, and that leaves me with the unit of grams in the top box. Now when you're done converting your problem, when the unit that you've been seeking out in the problem ends up in that top last box. This gives you permission now to go to the calculator and to simply process your answer. So when you go to the calculator, you would type in 23.7 times 1 times 10 to the second, or times 10 to the second is also fine. It'll give you the same exact answer. And that ends up giving you the answer of 2,370. You might want to pause here, practice getting that into the calculator, and make sure that you can get that same answer back out. Your calculator may also give you the answer of 2.37 times 10 to the third, and that would be completely fine. It's the same number in scientific notation. Now, a common misconception at this point is that the 10 to the value always has to be on the top, and that's not true. I want you to get it in your heads now that the 10 to the value is linked to the base unit. And the base unit is only ever going to have one letter. So if the one letter in your equivalent statement, that second fraction that you're putting in, if that single letter is on the top, then the 10 to the value is on the top. If the single letter is on the bottom, then the 10 to the value is on the bottom. And I want to give you a second example so you can see this in action. So what if I changed my problem to instead having 23.7 grams, and we want to convert that into micrograms? The problem starts the same way. We're going to take what we're given and turn it into a fraction by putting it over 1. So I'm just going to take my 23.7 grams and put that over 1. Step 2, the unit that I just put in there is going to travel down to the bottom of the next box. So grams gets copied down into the bottom because I want to get rid of it. I want it to be able to cancel out. Third step, go shopping for a unit. I know that I need something between grams and micrograms. So over in my metric conversion store, I see that I'm going to need to put a fraction that's equal to 1 in this spot to be able to effectively go from grams to micrograms. So if you go shopping in your metric conversion store, you see that you have something that fits the bill, something that goes between micrograms and grams. So now it's just a matter of getting the right numbers in the right spots. And since you took the time to cross your unit from the beginning down to the bottom of that second fraction, now you know where to put everything. So my grams, you can see in my metric conversion store, has a 10 to the negative 6th in front of it. Simply put that number in the right spot. It goes right there on the bottom, 10 to the negative 6th. And then in the top half of the fraction, we get the other half of the equivalent statement. So the 1 microgram ends up going up to the top of my fraction. Now I have everything set up, and I can cross off like terms. So I have grams that are exactly the same from the top to the bottom of my fraction. You can go ahead and cancel them out. That leaves you with nothing left over except for the unit of microgram at the top. And I know that I'm done my conversion when microgram is on the top last box, because that's what my problem wanted you to convert into. Now you're ready to go into the math. So you pick up your calculator and you're going to type in 23.7 and then divided by 10 to the negative 6th. And we're going to divide by 10 to the negative 6th because it's on the bottom this time. Once you plug that into your calculator, you should be able to get back out the answer of 2.37 times 10 to the positive 7th micrograms. Now you should have pages and pages of practice problems, so I want you to go ahead and try a couple out until this starts to become more natural. Then you can move on to the more complicated two-step metric conversions.